Yeah. So, hello everyone. Hearty welcome to all the attendees of this webinar. I am CH Naganoshit, AI research intern currently working in Salesstrat AI Lab. Today's webinar topic is about generative AI concept, which is text to video generation. First of all, I'd like to thank Vivek Singhal sir for giving me this opportunity and the entire Salesstrat team. Uh, and I am CH Naganoshit, as I told earlier. I am currently pursuing my final year of engineering in Dayanand Sagar College of Engineering under the Artificial Intelligence and Machine Learning major. To start off with the webinar, uh, so we have been under Salesstrat. I have been also effectively working on generative AI concepts and trying to develop fashion products so far. Now I have got this opportunity to present this webinar, and we'll start straight away. So speaking of text to video generation, what comes to your mind initially? Like text to video generation, we give a particular prompt, let's say a prompt of 2 or 3 lines, and we have a video associated with it. We have been looking at text to image generations for quite some time now, but text to video is something which is still in extensive research. So text to video is more complicated than the text to image generation and involves lot of complexity. So let's start off now. Text to video generation is a computer vision task which involves generating a sequence of images from text descriptions, as I told previously, but we have to ensure that temporal and spatial consistency with respect to the video generation concepts. Here in this webinar, we'll clearly review the differences between text to video and text to image tasks and discuss the unique challenges of text conditioned video generation. Additionally, we'll also try to cover the evolution of the text to video generation models, and what is the current state and what are the future prospects that we can explore in this domain. And we'll also see an implementation demo of text to video generation model, that is the demo lab model by Model Scope. So that's it. That's about the introduction. In conventional text to image generation models, we basically see the usage of GANs, that is generative adversarial networks. These GANs consist of two submodels mainly, which is the generator and the discriminator. The generator is responsible for understanding the prompt and sending fake samples to the discriminator, whereas the discriminator distinguishes between the fake and real samples based on the trained data it previously has and tries to produce an output. So both generator and discriminator kind of go hand in hand, and they try to generate a particular image based on certain criteria. So let's take the example of generating a flower. Let's say we have to generate the picture of a flower. So we have the generator, which will send fake images of a flower, and the discriminator with the real-time data which it is previously trained on will try to distinguish between the fake samples sent by the generator, and will try to compare the fake samples sent by the generator and the real sample it has. So based on this comparison, the GAN models work. So this comparison will lead to, they go hand in hand. So basically, when a discriminator suggests a change, when the discriminator distinguishes the image generated by generator as fake, the generator has to update itself and then send another image to the discriminator until this process continues, and both are interrelated, reiterates until the discriminator is able to is not able to find the distinction between a real and fake sample. So this continuous fine-tuning process happens between the generator and iterative submodel, generator and discriminator submodel. But why I have discussed this architecture is to establish the clear-cut difference between text to video and text to image models, because in text to image models it's just a single frame, so we need not focus much on temporal consistency, whereas in text to video models temporal consistency is of utmost importance, because we need a series of frames to conjoin together, and a video has to be produced based on that. So we have to ensure that visual consistency and temporal consistency at the same time. So that's why I brought up this topic. Are we clear so far? Like, are we following? Is everyone able to follow? Everything is fine?
Yeah, hello folks. Let's ask a lot of questions to make it really interactive and collaborative.
Yes, yes. I want you guys to speak up. If I have missed something, you can suggest me, because there is a consistent process of knowledge sharing. So I want you guys also to be interactive. And let's, for the next 1 hour, let's focus on experiential learning throughout. Right? I'll continue.
Nashit, one question.
Yeah, tell me, ma'am.
What is the motivation of using GANs in the world of diffusion models, like in the previous slide?
Yeah, yes, ma'am. I just wanted to explore the evolution of models, basically. So I'll be going to the diffusion model concept in the later stages, but I just wanted to establish a clear-cut difference and what are the advantages of using diffusion models over GANs. So I'll be speaking of that later.
Okay, sure.
Sure. Yes. So these are the practical challenges that we can think of in video generation, and why GAN doesn't, be the best suitable option for us to work on text to video models. First thing is our computational and data limitations. So as I told previously, we have to ensure that spatial and temporal consistency across frames. But what so happens is that the computational resources which are present currently are not really sufficient for complex AI models. I faced a real-time issue while trying to show a demo while executing a particular text-to-video generation model. I tried to use the open source stable diffusion model, and my GPU or my CPU was not compatible. So the availability of resources and the cost for purchasing those resources which required for execution of these video text to video models is quite expensive. And we also have this problem that we don't have sufficient amount of quality data sets which can be used to train these text to video models so that we can create a full-fledged video. Currently we have quite a few data sets, but we need more additions. Like, we need the size of the data set to be larger. We need more features in the data set, and currently we have confined data sets. Today, the example we have used, the model we have used has made use of a WebVid data set, which we'll be looking at in the later stage of this webinar. But there is definitely a lack of quality data for us to execute or implement these text to video related models. And while prompting is, as we all know, prompting is a very major stage in generative AI models. And for a video to be generated, a detailed prompt has to be provided. Like, if you just provide a single line prompt, it might not turn out in the way you anticipate. So we should have clear prompts and clear descriptions to be given for us, our video to be generated according to our imagination and to meet our requirements. So prompting is also a concern. I feel we'll eventually get through all of this, but since it's the early stage of the text to video conversion evolution, I feel these are the major challenges involved in this procedure. So let us look at the traditional approach which was used for video generation previously, and we'll also compare it with the current approaches we are using. So basically, we were making use of GAN and VAE, like that is ventilator associated event based approaches, which used to regressively generate frames for a given prompt. While these were working fine, but I feel their scope was very much limited. As you can see in the image provided below, there is only the motion of the video is restricted. We can't visualize many things. They are limited to lower resolutions. They are of a shorter range and isolated motions. Let's say if you take this example of digit 6 is moving up and down, it's just moving up and down. Like, this is just the beginning. But I feel when we want to explore the usage of text to video concepts at the scale of industry, this is definitely not sufficient. We need some finer models, finer architectures, which will efficiently generate videos better than this. So these are unidimensional motions where there is not much involved. You can take a look at this. But gradually, the approach has changed. We have moved from a traditional GAN and from GAN and VAE approaches to transformer architectures and diffusion architectures. So we have few examples where we have mentioned about the transformer architectures that are being used. Let's say we have a video GPT and Cog Video, which makes use of transformer-based frameworks for which works as a video generative model. The underlying architecture will be based on a transformer. And we have also seen, like, there also exists Fenaki, which is a very important, a very exciting tool for generating videos, where a sequence of prompts will be given to the model, and it's very efficient. Like the Fenaki model produces videos that seem quite realistic and are refined to the fullest. Other than Fenaki, we have also we can also explore the usage of Nuva Infinity, which proposes an autoregressive or autoregressive generation mechanism for infinite image and video synthesis from text inputs, enabling the generation of long HD quality videos. So we definitely have a great advantage of using these transformer architectures instead of the GAN or VI architectures that were mentioned previously. But the downside of this is both Fenaki and Nuva Infinity models are not available to the public, like it's internal. So the usage for common public like us is definitely limited. So that's why I haven't implemented any kind of transformer architecture. I have implemented a diffusion-based architecture, which we'll be going through with the demo later. But is the main reason. Even for not, we don't even have a free subscription option for these tools. So we can't implement those. We can't access their APIs. So speaking of diffusion-based architectures, diffusion-based architectures involves the process of diffusion. Like it makes use of a process where noise is imparted onto the input of onto the image generated based on the given prompt, and the noise is then removed gradually to obtain the prescribed output. So this is how diffusion based models work. We have we have several diffusion models in the video domain, such as the Magic Video, or the Runway Gen 1 and Gen 2, the text to video, or the demo YLab text to video generation by Model Scope, which we'll be implementing today. So these models are open source and are easy to implement, and the accuracy of these models is also fine. I won't tell it's great, but it's definitely fine, and it is industry relevant. So that's the reason I chose a diffusion based architecture to be implemented. It is very easy to implement also. I will show you a Hugging Face applications demo in the latest stage, but these are the latest approaches which these are the approaches which are used in video generation. First we looked at GAN or VA architectures, then we looked at transformer based architectures, and then we just came to diffusion based architectures. And we have several data sets available, as I mentioned previously, but these data sets are large. Definitely they are useful, but speaking of industry relevance, we need more quality data sets which can be able to generate complex videos and help us in industry relevant procedures. I hope we get to see these data sets, and under SalesStrat, I hope we will be able to make such data sets which we can use in our operations with respect to text to video generations. We can look at the various data sets that are utilized in video generation. First one is WebVid, which we have which our model demo Wylab text to video generation uses today. It contains close to 10.7 million pairs of text video pairs, that is close to 52,000 video hours, and it contains a fair bit of noisy samples with irrelevant video descriptions. Other data sets are also available, such as the how to 100M dataset, which consists of close to 136 million video clips with captions that describe how to perform complex tasks such as cooking, handcrafting, gardening, and fitness step by step. This dataset is highly confined towards those domain applications. So whereas WebVid is actually more generic than how to 100M or QueryYD or CelebVText. QueryYD dataset focuses on the event localization task, such that the captions of the videos describe the relative location of the objects and actions in detail. Other than that, we also have the CelebVText, which is a large-scale facial text video dataset, which consists of close to 70,000 videos, and it mainly captures the emotions, gestures, and the realistic face. So it is mainly a conversational, mainly used for generating conversational videos in real time. So that's about a basic intro of text to video generation and what are the data sets, what are the traditional methods used, what are currently being implemented, and what we'll also discuss about the future scope of this this domain, this text to video generation domain, and how our implemented model works on this diffuser libraries for generating our input prompt into the form of a video. So moving on next, are we clear so far? Like, is there something you would want to ask? Is there something you would want to share?
So today the state of the art, Naganoshit, is latent diffusion models, right?
Yes, yes, sir.
Okay, in Midjourney and Runway ML are state of the art for video generation or no?
Yes. Yes, sir.
So,
Midjourney, the problem with Midjourney is that it is mainly used for images, sir. So Midjourney just produces videos which focuses on the transition of the image, transition of a noisy image into a finer one. So Midjourney, I don't think we can use it for generating videos, at least at this moment. And it's with Midjourney, to access Midjourney, it is actually slightly expensive, sir. There is no free trial for Midjourney, and we have to access it by means of a subscription, sir. So I don't think Midjourney is the perfect way for us to move on from here. But for generating images, Midjourney has done a great job. But for videos, I don't think it's the right option, according to me, sir.
No, so Runway ML is ahead, you think then?
Yes, sir. Runway ML actually is ahead, is actually better than Midjourney, according to my opinion, because the quality or the smoothness of the videos obtained in Runway ML are superior than any kind of text to video generation model which we'll be implementing today. So I think, yeah, Runway ML is definitely a preferable option, sir.
So I think OpenAI and Google are still catching up on text to video. We haven't
Yes,
seen
sir.
any.
Yes, sir. Yes, sir. OpenAI has only DALI, the second version of it, and they are still catching up on text to video. There are quite a few models for text to image, but with respect to text to video, you can hardly see any models, sir. Like, it's still in the exploratory phase, where I feel there will be a huge transaction in the next 6 months or in the next 1 year or so. So if we are able to capture this market and build products on this domain, I feel Cellstrat will go way bigger than we can ever imagine, sir. So we have to explore this probability.
We are not in the business of training foundational models. Training foundational model needs financial muscle. So we generally are developing a business there on top of best of breed foundational models. So our strategy is not to compete with foundational guys.
Yes, sir, got it. But there is lots of scope in this particular domain, and if we can try to explore it somehow, I feel it will be highly profitable for the growth of our organization, sir.
Yes, yes, but you have to innovate beyond what exists, right? So that's not so
yes,
easy.
Sir. Yes,
so
yes, sir.
You need an army of the PhDs in artificial intelligence. So anyway,
yes, sir. Yes, sir. No deny. Yes, sir. Yes, sir. Yeah, sure. So we'll continue with the next part where I have implemented the demo by lab text to video generation model from Model Scope. So we'll just take a small introduction about how this model is, on what basis it is functioning, and then later we'll have a clear picture of how this model works. We'll try to look at the code at the same time and I'll try to show a live demo by giving a prompt, and let's see what the prompt generates in the future. So we are making use of a text to video synthesis model, that is demo by lab text to video MS 1.7b legacy by Model Scope. It is an open domain model and is a sure shot match winner, because there are hardly any models which will be able to which are fine tuned as much as this. So I which are open source and are fine tuned as much as this. It is quite easy to implement. We'll just be making use of a diffuser library which will look in the future. And the major disadvantage or the downside of this model currently has to be its lack of multi-language support. It can only take English prompts currently, but we can explore the probability of trying to build this model suitable to multiple different languages, and try to generate videos based on different uh, languages. So we'll try to explore that possibility also. But as I told you previously, diffusion-based generation involves the usage of diffusion process to create high-quality videos based on the text description or the prompt we have given. It makes use of a Markov chain. Just basically, what diffusion models do is they make use of a Markov chain to impart noise into the image. Let's say a Markov chain can be assumed something like the current timestamp is only dependent on the previous timestamp and not anything else. So it is a process of sequentially executing based on individual timestamps and imparting noise to the images. Based on the noise imparted, it will this diffusion process involves denoising the image to produce the generated image. Let's say the denoising process involves the usage of some kind of a convolutional neural network, which is unit 3D in the case of this model we'll use. This noise is the noisy image is basically passed through the unit 3D CNN, and the noise is removed in a sequential process to extract the image, the generated image accordingly. So the Gaussian noise which we'll impart. So basically Gaussian noise is that noise that is associated with Gaussian or normal probability distribution. So that noise will be eventually removed and an image is generated based on this process. So that's what is mentioned here. We have a set of different steps which we'll be following. First thing would be there will be a prompt individually given. We have implemented the diffusion process by means of a diffusion pipeline. That pipeline will will conduct all these individual noise imparting and noise removing process to generate a frame, and all these individual frames will be clubbed or will be merged in order to form a video. So the video we'll be generating today will be close to 25 seconds based on a given prompt. And the quality of this video which will be obtained is fair and good enough. But we need a lot more fine tuning for this model to match the relevant industry standards. So this is just a beginning. This is just the beginning stage. And we'll see how this model can be fine-tuned later, but I have come up with a basic framework for you to understand. And this image shows the basic process where the Gaussian noise is imparted onto the image, and how it will how the individual timestamps the Markov chain is indicated here, and how individual timestamps impart noise gradually to the image is depicted here. So we can take a look at the code now so that you guys understand this in a better way. So I'll just show you the code. Just give me a second.
So friends, let's ask a lot of questions to make it very interactive.
Yeah, just give me a second. It's connecting to the runtime and we'll start. So basically, we are using the diffusers library that is provided by Hugging Face, and also the utility library called Accelerate. That Accelerate basically allows PyTorch to run code in parallel threads. So this will definitely speed up our generation process, and we should install all the dependencies and import relevant modules for our code. So that's done here, and we'll basically focus on loading the pipeline, loading our model into the pipeline. For that, we have to create a pipeline first. So these are the libraries which we have imparted, which is Torch, and from the diffusers library, we have imported a diffusion pipeline and DPM solver multi-step scheduler. The DPM solver multi-step scheduler is more focused on handling the diffusion process within the pipeline. And from diffusers, we have also made use of the export to video library, which we'll be using in the later stage. So basically, we load the text to video model provided by model scope on Hugging Face in the diffusion pipeline. This model has close to 1.7 billion parameters and is based on the unit 3D architecture. As I mentioned, the unit 3D architecture is responsible for the denoising process of for the video generation aspect. And so this entire process works in mainly three steps. At first, the model performs the text feature extraction from the simple English prompt, which I have mentioned here. From this English prompt, the text features are then encoded into the video latent space and denoised, where we make use of the unit 3D unit 3D architecture, and the visual space and a short video is later generated. So you can look here, we have given a particular prompt and we have obtained individual frames with that. These individual frames will be converted into a video by making a video path, which will be later.
Sorry, what was the prompt again?
Prompt is a panda roaming on a rock. If you want, I can change the prompt, sir. Or if this is fine, I can show you.
Well, this is fine.
Yeah, so, a panda roaming on.
Okay, so, yeah, so you're creating video frames.
Yes, sir.
Okay.
Yes, sir. Individual video frames.
Series of video frames. The number of frames 200.
Yes, sir. A series of video frames, which will be later clubbed together in order to obtain the final video, which we can download, sir. So that's the basic idea.
Command, you're saying this pipe command can create a series of frames.
Yes, sir. Like the pipe command is usually involved for us to create a pipeline, and the diffusion process takes place with it. And then we'll have a series of frames generated. Like let's say we are working on frame 1. So frame 1 will be generated. Then it will be exported. Then frame 2. All of this will be exported together, and we'll obtain a continuous video, sir. Like a video which will have the duration of video around 25 seconds. It will be a repetitive video because we have a small prompt here. So I feel if the prompt should be even more clear and even more large for us to extract videos that we anticipate and which are relevant for daily usage. But this is just a small visualization technique which we have used, small visualization pattern we have used. I'll be using a simple prompt because it will take lots of time to execute, because I think for this prompt, it will take us close to 5 to 8 minutes for execution and conversion of that into a video which is in the downloadable form. So we'll go with a small prompt.
This code looks rather simple to me. I used to think we need at least DALI 2 or stable diffusion for good image generation, but here you are using the basic diffusers library from Torch, right? So and you're saying even with basic diffusers library, you are able to create a series of video frames which you concatenate to a video. So
yes, sir.
So this was already there. I didn't even need stable diffusion or DALI 2 to be able to do this, right?
Yes, sir. We haven't used Stable Diffusion or DALI 2 here. This is just a small implementation, sir. But yes, we can definitely use concatenation of video frames using complex algorithms such as Stable Diffusion or DALI 2 and generate videos. I haven't tried out that possibility of execution.
Hmm.
I have only tried out diffusers. So I'll be showing you the result which I have obtained today. And if
Sure,
there is a
sure.
possibility, we'll definitely explore that also. It's actually a very nice idea which I haven't thought of. We have used normal diffusers here, but we'll definitely try to implement with the use of DALI 2, and probably we'll share it in the official platform at a later stage.
Sure, sure.
Yes, sir. So shall I execute this one so that it will take
Yes,
around
yes.
5 minutes to execute? Meanwhile, we'll try to discuss other points from our presentation and come back to this after 5 minutes so that we can view the result. I
Okay.
will bet. I have already executed this and added this into my sample, so I'll give some other prompts, sir, so that it will be innovative.
Okay, I
Let's
have a
say,
question.
yes, sir.
I have a question. So
Yes, sir.
you have mentioned that Fenaki, about this particular Fenaki, uh,
Yes, yes,
that it is not available for public platform or public use, and it's only internal. So, like,
yes,
but
yes,
I
sir.
have seen that Fenaki has a very interesting value proposition. Okay,
Yes, sir.
right. So if we were to develop something equivalent to Fenaki, what are the series of steps that are involved that we should take as a developer, as an entrepreneur, as anyone like, in order to develop? Because I found Fenaki use case to be particularly interesting in your
Yes, yes, sir.
entire presentation, right?
Yeah, got it, sir.
And another question to me, sorry to ask you the second question, is that
Yes,
in this particular collab notebook, you mentioned about this particular thing called accelerate, right?
yes, yes, sir. Yes, sir.
Okay.
1 second, sir. I'll
And
show you once.
yeah, can you show me that particular collab
Yes,
notebook?
yes, yes, sir. Here it is. Is it visible, sir?
Yeah, it is visible. Yeah,
Yes,
accelerate. There you have called accelerate. And can you go down?
yes,
Can you go down? There is a particular line. Yeah, yeah. There is a particular line here which says optimize for GPU memory.
yes, yes, sir.
Yeah. So
Yes, yes,
when you're calling that function, enable
yes,
model CPU offload,
yes,
right?
yes, sir.
What exactly happens? I mean, is there a ability for us to debug this code and see what exactly is happening under the hoods?
Sir, the reason why I have used this is my GPU is not really proficient in handling such kind of tasks. So I was doubtful of whether my GPU memory is sufficient enough for me to handle this task. So I have used I have made the model to work on the CPU at the same time, and it's basically management of computational resources, sir. Nothing more than that. And I feel
No,
the
no, no,
main
no.
reason for it is to
No, what?
optimize the performance of the model, sir. Nothing more than
Correct,
that.
correct.
By offloading
No,
it to the
what?
CPU.
Yeah, what I'm asking is when you're specifying accelerate at the top of the collab, uh,
Yes,
and
yes, sir.
and so what is the optimization in percentage terms? Uh, what is the optimization in terms of GPU memory?
I'm afraid I'm not really sure about that, sir. But the reason I used accelerate is to because as I told you, it takes lots of time to generate a 25-second video. So I wanted to fasten this process and obtain results in an faster and efficient manner. So that's the sole reason of using. And we also wanted to execute multiple threads in Torch. So that's the main reason we have used accelerate. But I'm not very much proficient with the parameters you're asking, sir.
Okay, no issues about that. That's okay, fine. So can you answer my first
Of course,
question,
of course.
like Fenaki?
Yes, yes, sir. So basically, Fenaki uses underlying architecture which makes use of which makes use of transformers and a combination of diffusion, but mainly transformers basically. So we'll have to come up with a novel architecture first, sir. And coming up with a novel architecture is a very big task because some components might work together, some components might not. So it is definitely a tedious process. Once you come up with an architecture to monetize this product, we need some kind of proper way in which we can build the product. Coming up with the architecture will not just work. We have to fine tune the model. We'll have to make sure the model is working according to the industry standards. So we'll need some amount of time to reach to the level of Finaki, but I feel it is definitely not impossible. We can get there, and we are almost around the corner if we have that right determination, and if we come up with the right architecture components with the continuous fine tuning of the models and the architectures we have developed. I feel we also can definitely implement this kind of products in real time, sir.
Thank you, sir. That's it. That is my two questions, sir. Yeah.
Yes, sir. So I'll go to the PPT until this is. Yeah, I think we are done with this. We can look at the video. Just give me a second. The video obtained will be in the standard MP4 format, and it will be close to 25 seconds. Let's see how it will turn out. So basically, we can download the video into our local device. And yeah, so the prompt we have given is Spider-Man is surfing. And here we can lively see that Spider-Man is surfing on a water body. So
no, we can't see the video. We can't see the video.
Okay, just give me a second, sir. I will share my screen. 1 second.
I'm very excited to see the video actually.
Yes, sir. 1 second. I think I have to share my
text to video is something indeed we haven't seen much.
Yes, sir. I think I have to share my entire screen. I will do that. Shit. And this is the video which I just downloaded, sir. Like I can show you in downloads only if you want to. Or yeah, I think this is fine. This is the video of Spider-Man surfing. So I have already executed a couple of prompts previously. I can show you that also after this is seen. So it's a repetitive process. Since our prompt is small and we have used a simple diffuser model, I didn't try to complicate our prompt. It's just a single line prompt. We have to explore the possibilities of trying to generate videos which are greater than 25 seconds at the same time, and which are more smooth, more fine-tuned than this. I'll probably explore on that in the later stages. Yes, ma'am. Sure.
Yeah. So in the video, I think there was a display of Shutterstock. I guess.
1 second, ma'am. I think this.
Yeah, that would be a copyright problem. Yeah.
Yes, ma'am. That is actually a copyright problem that we have seen with all kind of videos, ma'am. I'll show you the videos which I have implemented in my presentation also. So that
is it the model trained on all the Shutterstock images? That's the reason it has, or?
Don't know, ma'am. Since we have not developed the model from the beginning, and we have just implemented the Hugging Face implementation. So I'm not sure of the development and the training data set. The training data set they have used.
So you have used the demo VLab, right? Demo VLab from Hugging Face.
Yes, ma'am. Demo VLab. Yes, ma'am.
So does that mention that it's trained on the Shutterstock images, or?
Yeah, there could be a possibility of that, ma'am. I am not really sure with that. But generally, what happens is when we are not building the model, we don't know what are the features they have used in their model. We can't know what kind of architectures or what is the internal working of that model. We have just implemented that now for the webinar purpose. I'll definitely, as you have raised this question, I'll definitely explore the possibility of how it potentially works in a detailed manner, and I'll definitely get back to you.
Yeah, let me augment that by saying that currently there are tons of legal lawsuits. Getty Images and many others have filed a lot of lawsuits on these GenAI companies because GenAI companies have happily scraped the internet data from Getty, Shutterstock, right? All these stock photo websites.
Yes,
And so
yes, sir.
I think that is one of the blockers why we have not seen, let's say, text to images, text to video take off big time. So there are outstanding lawsuits which are pending in US courts and all European courts from these content companies on GenAI companies. So still a lot of work remains where we can solve this, because we clearly can't rely on these, because if you develop products using this technology, you are liable for legal action by these content companies, right?
Yes, sir.
So
Yes, sir.
we can't really launch these products actually, because they are
Yeah.
scraping internet data without
Point.
permission.
Yes, sir. I agree with that point.
can remove the watermark,
Okay.
I mean, using.
So does all the
What's
videos you generated earlier has the some watermarks like this, or?
Yes, ma'am. Yes, ma'am. I'll show you that. Just give me a second, ma'am. Is my screen visible now, ma'am?
I think it's coming up. Yeah, it is visible
Yeah.
now.
No, it is visible now, right? Yeah. So you can take a look at, these are the videos which I have generated previously, ma'am. If you can take a look, I have even mentioned the prompt there. An astronaut riding a horse on water, that is realistic. And we can potentially see the watermark, but at the same time, it has generated the video in a realistic manner. Like, that's what I was also impressed with when I implemented in the beginning. It is basically a repetitive video, but it has performed well. I have one more example also for you to just confirm this. A panda roaming on a rock. So I think the accuracy of the prompt is fair enough. It's generating videos. The quality of the videos is not really high. It's not Ultra HD. Even if I try to mention the point of Ultra HD videos in the prompt, I'm not able to generate that. So I think a bit more fine tuning and smoothing is required. And one thing which stopped me from exploring all of this is my lack of computational resources. I'm working on my personal computer. So I feel to implement complex architectures or to implement complex text to video generation models, it is basically difficult for me with my local device. So we need high intensive GPUs because there are certain models which demanded a basic requirement of 16 GB of RAM and high-end GPUs. So I feel that was a major limitation for me while executing these projects. But I executed whatever was in my hand, whatever I could do with respect to text to video generation, and the output is clearly evident here. We have,
Okay.
So
I have a question.
yes, sir.
Okay, so this is with respect to this Spider-Man on the water. Okay.
Yes, sir. Spider-Man is surfing. That's all. Nothing much.
Yeah. So if I want to change the Spider-Man to Superman,
You
okay,
can do it, sir. Like, we can do it.
Yeah. Can you tell me which lines in the collapse source code, the notebook, need to be changed in order for me to change from Spider-Man to Superman?
It's mainly the prompt, sir. The prompt we'll give is what is
Can
taken
we-
by.
Can we
I
go
have to show you
collapse?
Yes, sir. Give me a second. I'll share you that window.
Sir, it's simple prompt engineering. You have to give
It's-
what kind of input require, you will get
Yes.
it. Very simple.
Yes, sir. I will showcase it to you. 1 second. So here we basically have Spider-Man is surfing. Is my screen visible, sir?
Yeah, it's visible.
Yeah.
Okay.
Yeah, we have Spider-Man is surfing here. So instead of Spider-Man, if I give Superman is surfing, we'll get an image of Superman. So it's basically a prompt. So what happens in the backend is the prompt which we give is interpreted by the model which we have executed, and it will try to match Spider-Man with the Spider-Man in their dataset, in their training dataset, which they have used as WebWid dataset here. And then based on that, the video is generated. It is basically done
Okay,
within the diffusion pipeline.
that is fine. But in this data set, what is the probability that there will be a Superman?
It is basically, as I showcased you previously, there are quite a few millions of points and millions of videos within this WebWid data set, sir. So there are high chances that Superman will be a part of this data set which they have trained on, that is WebFit.
Okay, can we change that Spider-Man to Superman and see whether that image comes or not?
Yes, sir. We can definitely give it a try, but it'll take some amount of time to execute, which we have to wait. We'll do it.
No, Srini, that has to do with word embedding architecture, right? So because this is textual prompt, it has learned from the internet at scale. So it has learned the meaning of the entire word dictionary, if you will. So even it may not have maybe Superman photos per se, but it has trained on internet scale data. So it has seen almost everything there is to see. Okay, so in that way, maybe it has seen everything there is to see. Now, if you give some new superhero character which don't exist
anything. No, what I mean to say is that instead of having Superman, or as Vivek has told, any prompt where we need to see whether that image comes or not as an output. Okay, so what is that prompt where the image might, where the training might take a lot of time, more than 2-3 minutes, more than 5 minutes, or the image might not be there in the data set. So how do we know as a human being, okay, what are the images? Because do these data sets reveal publicly the images that are contained?
To be internet data, right? Most of the time it's entire internet data. So if it is there somewhere on internet, it probably has seen that, right? And learned the characteristics.
In majority of the cases, that is the case, sir. But at the same time, we can't train Naganoshit being wearing a Superman attire with respect to this model, because the model doesn't know who Naganoshit is. We can train it with Batman, Superman, Iron Man, or any kind of popular characters. But for customization, we have to train our photos into the model, and then we'll be able to do it, sir. Let's say there is this option where we can identify ourselves as a keyword, and we can train our pictures into the model and then obtain output in a customized format. We can make sure that Naganoshit wearing red hat and walking on the streets of Manhattan. So this is something we can execute, but I don't think it is possible with this model. But there will definitely exist a model where we can customize it according to our requirements and obtain the output, sir.
Okay. Thank you.
Yes, sir. So until this executes, we'll look at the remaining slides of the PPT. One sec, just give me a second, sir. Yeah, is my screen visible now? Hello? Yes. Yeah, it is visible. So so basically we have implemented a diffusion-based generation model, and it, as I told you, it is providing good quality of videos up to accurate details, but it needs a lot more fine-tuning with respect to smoothing and the clarity of the video, which I'll try to explore in the days to come. The main application part of this video generation is that I see in the next 5 or 10 years, the movies which we see on a day-to-day basis will be AI generated, or if not the entire movie, at least particular scenes or bits or some kind of AI innovation will come into mainstream media, which is not just movies, but marketing videos or educational video requirements. All of these will definitely have some or the other usage of AI to up to different extents. We can mainly use these text-to-video synthesis model for education and training purposes, where repetitive processes are involved. Let's say a student has to learn a course which involves lots of repetition, like he has to recall the contents quite on a quite regular basis. So I feel this application, this text to AI generation will definitely facilitate him there, because once the video is generated, he can look into that a number of times. And it is also like, if we can eliminate human errors in this process, we can eliminate human intervention in this process and gradually move towards AI videos in real time. It can be used in social media. It can be used for entertainment purposes, such as Reel or in some kind of exciting entertainment content. We can also make use of this in marketing and advertising products with respect to our organization, where we can create AI generated videos and we can showcase it to the public, make it more interactive and refined, and try to gain more customers into the organization. So these are the practical applications which I can remember of currently. So I have mentioned them. As I told you previously, the only language which this model currently supports is English, of different slangs, of course, but we have to explore the probability of making it multilingual, because multilingual products definitely have been in demand in the past times, and we'll definitely explore that possibility also. We'll see how we can implement this natural language of another languages, of various languages, and try to create videos from that. We'll definitely explore that possibility also in the days to come. And as I've mentioned, I have told you all of the steps which we have previously performed. Let's look at the video which would have been generated by now. Just share the screen. Give me a second. Uh, yes, sir. Like it's not clear that it's not able to visualize Superman perfectly, as you told, but it has understood the prompt. But I think there is an issue with the fine tuning of the model, which we have to work on. We can see a basic structure of a Superman, but not as a profound person. So we'll have to work on this.
No, the video
As you
was
mentioned.
not shared actually. You need to share the video screen. We can see it.
Oh, sorry, sir. I keep forgetting this. 1 second.
Okay, I have one small question. Okay.
Yes, sir.
Is MP4 the only extension supported, or we can have other extensions like FLCC also?
For this model and for the basic Python libraries, we have the export to video we have used. It's basically MP4, but we have to explore the possibilities of using other extensions also, because we have to definitely have alternatives. I'll definitely explore the possibility of looking into other extensions, and we'll get back to you, sir. According to my knowledge, it's just MP4 currently.
Okay, because I read somewhere that FLCC is more accurate than MP4. Somewhere on Google I read.
Yes, sir. Yes. Actually, it is more accurate, and it is more of a high quality of processing. But currently, it's only MP4 that we can use, sir, because that's how the library is designed. We have just used the pre-fed libraries in Python, so we can't make much changes into this.
Okay. Okay. Thank you.
Yeah. Yes, sir. And the Superman video, as I mentioned, it hasn't been clearly. We can't observe it clearly. There is, I think, some issue with the execution of the model. It has to be fine-tuned a little. We have to add certain features into this. I'll explore the possibility of all this, and we'll share it with you once the model is perfectly ready. This is just a basic implementation.
Thank you, sir.
Yeah. 1 second. Yeah, right. My screen is visible, right? Yeah. So what you guys do think, what might be the probability of using this text to video generation? Which are all the fields where we can use? What are the use cases of this? Is there any idea? If you want to talk, like if you guys want to speak up, if you have any idea?
This model can be pretty much useful for children who wish to just type some text and then generate some image, because they are more curious. It is for the curious mindset people who would like to see what is the resultant image out of me typing some prompt. Okay.
Yes, sir. Yes.
So something like I can type some prompt to generate a vegetable dish, a vegetarian dish. I can type some prompt to generate a video that is more expressive than the text-based format.
Yes, yes, sir. I got it. Yeah, that's actually a very nice use case. Basically, you can just type whatever is on your mind, and you will be able to visualize that. It's as simple as that.
Yeah.
But we have some amount of time to reach there eventually. But that's what we should be looking at in the end. Like not in the end, but that's what we have to be aiming for right now.
Yeah.
Yes, sir. Other than is someone has raised their hand.
Yeah. So
Yeah,
hi all.
yeah.
Om here. So one more use case that I can see is like there are a lot of like food industries or many car industries are there who are trying to come up with new models and new ideations. So they can use
Yes.
this for that modeling, like coming up with new styling. Otherwise, like coming for a celebration wise, for example, Christmas, and Pizza Hut wants to make a video out of it, instant, good looking video. So they can use this
Yes.
to make advertising.
Yes, yes, sir, definitely. And with this, we can also remove the intervention of visual designers, because if we are able to build a model which will automatically apply visual designs into our videos, I feel it's of great use. So that fine tuning has to be done to the models. But if we eventually get there where we can build models which can apply graphics or visual effects, I feel we have a great breakthrough there. And we have something from Nishant Chaudhary. I feel going forward 5 to 10 years down the line, it will help in remote patient operations. Yes, of course. Yeah, they say will, for in the industry, but I guess, but AI generated videos could be more economically. And yes, exactly, Nishant. We can definitely use this in the fields of healthcare. I have already studied certain papers where GenAI is being used to treat and visualize certain concepts even without scans. So it eliminates the process of going for scans initially, and we can visualize what the patient's condition might be. And the scans can just act as a confirmatory volume. We can predict or we can basically visualize what are the adverse effects, what is happening inside, by just giving certain prompts, and we can assess this case in a better way. So there are quite a few articles based on this. If you are really interested in using GenAI in healthcare, you can explore that probability also. It will be very useful. Gautam has to say will be very useful for training videos, say to augment user manuals of products. Thanks for the informative webinar. Yeah. Sure, Gautam. Yeah, we can definitely use it in augmenting user manuals of products, because these manuals which we get with built-in with the products are very much text oriented, and we can hardly visualize anything. So that's of a great use case which you have mentioned. So yeah, I would like to mention a few use cases which I have researched from my end. I'll just my screen is visible, right? Yeah. So we can, if we provide the entire script of a short film or a short video we want to generate, the model which we build should be capable of generating that video which we visualize according to our script. So if this is possible, it's a great breakthrough in the entertainment industry or in the business or marketing sector, because whatever is on our mind will directly be translated into the form of a text and a video in less than 1 or 2 minutes. So this is definitely a great use case. Along with this, we also have text to video models which can generate videos from long form text, which can generate videos from articles, blogs, or text files. If we are able to upload the entire text file, let's say upload the entire user manual, we'll be able to visualize how to set up a particular product. So this is one more very interesting use case. Other than this, we can also make use of voiceovers and speeches. to create an AI newscaster to deliver daily news, or for a filmmaker to create a short film or music video. So we can deliver daily news by feeding information into the model, and this AI will be able to read through the news for that data which we have provided. I think this is already being implemented in certain parts of the world. I remember reading a couple of articles with respect to AI news reader. Have you guys come across something like this?
Yeah.
Yeah, so it has already been in the implementation. If not this, we also have this methodology where we can edit our previously existing videos. Let's say you want to crop out a particular part of a video, or you want to increase the smoothness, you want to increase the brightness, or any kind of video editing functionalities can be implemented by means of a prompt. You need not get your hands dirty. So this is where a prompt will transform the video into your required format. Other than we have also mentioned the point of text-driven video prediction, where we can predict the spread of a disease, or we can predict the extent of spread based on the prompting and based on the visualizing capabilities we have. We also can perform video translation, where we can, if the video is in English, let's assume this webinar is currently being recorded in English and I want to translate it to Kannada. So my model should be capable of translating the audio into Kannada immediately by means of a single prompt. So if we are able to build products like this in the near future, I feel it's a great breakthrough in the field of GenAI, and it will definitely make our lives a lot easier than what it used to be before. So that's about the potential.
Sir, I have one question.
Yes,
Okay.
yes, sir.
Yeah, see, basically, this is like a very fascinating, interesting architecture built up by this, tech majors. They have
Yes,
like a lot of money, money to pump in, and they have like the ability to rent out the VM images on Azure or AWS portals, right?
yes, yes, sir.
So the basic thing is that it is very complicated process, manpower required, hardware required, everything is required, and there are like lots of bits and nuts and bolts, which most of the people are not aware in the industry. So a lot of research is required, everything is required in order to build a
Yes, sir.
model. Correct, right?
Yes, sir. Definitely. Yes,
Definitely.
sir.
But what is the monetization in this? Like once you build a model, like like a panda, of course that will not generate money. It is only for simple illustration purpose, right? But
Yes, sir.
with your knowledge, with your expertise, can you
Yes, sir.
let us know? Can you let us know what are the specific use cases which will have a monetization aspect involved in that? Like if I build this particular model based on this use case, there is a probability that I can generate money out of that particular API.
Got it. So what so happens, I'll talk about the use case first and then the monetization part, sir. So what basically happens is, let's say we have a marketing campaign about our product. We have to sell a phone. Let's assume we have to sell a phone. We have these Samsung or Apple ads circulating all over the internet. And this ad making involves lots of complicated steps. Let's say we have to get actors, we have to make them act, and then we have to, we have to have a proper supply chain where we have to send it to various platforms, where we have to deploy it on various platforms, and then showcase the ad to the common customers. But with GenAI, what we can do is, let's say if we want to hire Shah Rukh Khan as the brand ambassador for our video, we need not get Shah Rukh Khan to shoot for us. AI will basically model Shah Rukh Khan into such a way that he's talking about Apple, he's talking about our product, he's showcasing it to the common public, and we can directly take it into the minds of the public that Shah Rukh Khan has endorsed for us. Yeah, of course, it involves lots of legal issues and legal complications, but I just gave Shah Rukh Khan as an example so that you'll understand and be able to relate better. So it is definitely cutting our time and effort. We are investing small amount of time. We are giving a small prompt which says, "Hey, give me a video which will tell our model, will
You're not
prompt
gonna
our
shoot.
model."
I shared the Shah Rukh Khan Cadbury ad. This is exactly what they did. If you were
Okay,
to
I
just
was
share,
actually not.
if you see in
Yes, sir.
chat, you can just play
Yeah,
that
yeah.
video. This is exactly what they did. They
Once,
superimposed a voice on Shah Rukh Khan's, lip
yes,
sync
yes,
for
yes, sir.
variety of retail advertisements.
Got it, sir. You want me to play it or?
You can play it, but you'll have to share that screen, the YouTube screen.
Yeah, got it, sir. I will share it. 1 second. Just give me a second, sir.
This was
I
a
will
lip
play.
sync, sophisticated computer vision lip sync. It's an Indian startup, in fact, funded startup, and sophisticated computer vision lip sync on Shah Rukh Khan. Advertising variety of local retail stores.
Okay, I didn't know this, sir,
this
but I
video
use
was-
Shah Rukh Khan because it's a very popular example and everyone will be able to relate. That's all.
But obviously, they had an agreement with Shah Rukh Khan. Otherwise, Shah Rukh is going to sue all over, right? So
Yeah, that's what, as I mentioned, it will involve legal complications, but it reduces lots of effort. That's my point to sir's question. Like, how is it monetary? It'll reduce our effort. We can take it into the public even in a more effective manner. This is just one of the example. Let's
just
say
play
we
this
can.
video.
Yes, sir.
Businesses and brands that suffered during the pandemic found their way back, but the smaller stores still suffer.
This lockdown has been a real tough phase of my life.
Forward it a
I have
little
seen
bit.
bad days, but this was the worst.
Last year, we helped small businesses through Diwali. So this year, we decided to bring it back. Presenting not just a Cadbury ad. This Diwali, we helped hundreds of small businesses by making India's biggest brand ambassador be their brand ambassador.
इस दिवाली आप भी ना अपने पास वाले फैशन ऑफ एम्पोरियम से ही कपड़ों की शॉपिंग करना और फिर एम्पायर फुटवेयर नाम तो सुना होगा अपना स्टाइलिश चश्मा बगल वाले हेवन आई ऑप्टिशियन से ही लेना सिद्धि विनायक इलेक्ट्रॉनिक्स से लेटेस्ट स्मार्टफोन खरीदकर धमाकेदार सेल्फी पोस्ट करना
क्या कर रहे हो मीठा लाए कि नहीं
लाया हो ना यार अपने पास वाले रोशन किराना से आप भी अपना मीठा वहीं से लेना
We used machine learning to recreate Shah Rukh Khan's face and voice to take the local store names in the ads.
इस दिवाली आप भी ना अपने पास वाले चॉइस ऑफ फैशन से ही कपड़ों की शॉपिंग करना पास वाले आजकल फैशन से ही रॉयल फैशन से ही एमके क्लॉथ्स से ही पास वाले लक्ष्मी कलेक्शन से ही कपड़ों की शॉपिंग करना इस दिवाली आप भी ना अपने पास
Different versions of the same ad with local store names were targeted as per the PIN code of the viewer, showing them only the nearby stores. But it is impossible to cover all the stores. So we gave the power to the people to create their own version of not just a Cadbury ad. Any small business owner could promote their stores through their own social media networks like WhatsApp forwards and other social media pages.
मैं भी नहीं सोचा था कि शाहरुख खान मेरी दुकान का ऐड करे।
हमारे आस पास की जो दुकानें हैं
Yeah. So there was some sophisticated computer vision, with the key point estimation on lip movement and face gestures. So this can also be considered GenAI, I guess.
Yes, sir. This is one use case. Like this, if we sit and explore, I myself can think of 10, and there'll be millions. So monetization should not be a major problem if we can build a full-fledged product. But building a product is the difficult part here. It takes us lots of, as you told, it takes us lots of effort. It takes us lots of research to build a product. We need complicated servers to deploy our products on. So that's a very valid point. But once if we are able to build a full-fledged product, I feel scaling this and monetizing this is not a great issue according to my knowledge. Is my question answered, sir?
Yeah, definitely. Yeah.
Yes, sir.
Yes,
So we have just
we can discuss monetizable product ideas. I mean, that's what we do in Selstrat, right? We have many folks in the Selstrat community developing variety of products and startups.
Yes, sir. We'll definitely work on monetizing, or we'll definitely work on how we can take this forward. So that's about the model use cases. And basically, what is the limitation of the model we have implemented today is that there, as we have seen, there can be training data deviations. This WebWidth data set will have so many data points, and it is actually a public data set. So that's why you could clearly see we were not able to visualize Superman perfectly. I think this might be one of the issue where we were not able to visualize, but we'll see what we can do with that. Quality limitation, like the video which I generated is around 480p, I guess. But currently, in today's real world zamana, it's 4K or 8K that is in demand. So it doesn't meet industry standards, but we definitely eventually have to get there, and we have to fine tune our model in such a way that we'll be able to produce the efficient results according to the current relevance. And language support is something which I have previously mentioned, and complex compositional generation. The performance of the model needs improvement for complex compositional generation tasks. Yeah, so as I told, fine tuning of the model is the major part here. The execution of the model is actually quite easy, but fine tuning requires lots of research and time. I'll figure out in which ways it can be done. So these are other limitations. Realistic representation can be one concerning factor, because majority of the images which we see are mainly graphically generated. But to make it look real, it requires lots of work in the backend. So we have to see how we can implement that. And there are chances of this product being misused also. This is the downside, where prohibited content generation can happen, and we might be the model. It generally generates based on the prompt, so we definitely can't tell what kind of prompt the user is going to give. So prohibited content generation is a worrisome factor, where violent or explicit content can be generated, but we have to find a way where we have to limit this and make sure we're following all the right ethics, and we're not committing any offense here. So that's about the limitations of the model, of the text-to-video model that can be implemented. So we have reached the conclusion part. I think we have explored the various ways in which the evolution of text-to-video generation has taken place in the past, and we have tried to look at a live demo where we implemented demo YLab text-to-video generation model by Model Scope. And it's this open source tool. With this open source tool, we were able to visualize a video, a couple of videos actually. And other than that, we have tried to understand the use cases and applications of the text-to-video models and architectures. I think that's all from my end. Vivek sir, you want to add something?
No, that's all good. So, audience, any questions for Naga Noshid? Final questions?
Yes.
Om.
Yeah, please tell.
Yeah. So I see that there's a lot of use cases are there, but a lot of responsible AI also needs to be taken care of. Like images of various different genders have been in the name of LGBTQ has been exploited, going for this text to image and even if image to video type of conversions. So some type of regulations is required over there, and plus a lot of consents has to be taken. For example, the Shah Rukh Khan video. I'm not sure whether Shah Rukh Khan knows about it.
Yeah.
Recently, there was a case by Tom Hanks that his video was used to make this AI avatar where they're selling some medicines without his consent. So
I got it.
Some regulations has to be there.
Good point, Tom. But
Yes.
by the way, that Shah Rukh Khan was an orchestrated ad. Shah Rukh Khan signed an agreement with Cadbury, so Cadbury won't make that mistake, right? It's a very reputed brand.
Yeah,
Okay.
the reputation of the company is such, but Om's point is actually valid. Cadbury is a big company, so it will definitely get into a deal with Shah Rukh Khan. But what about very, very small enterprises who want to mislead customers base using celebrities' fame? So it is definitely a concerning aspect, and proper regulations have to be observed and taken in order to use this as a full-fledged product. Very, very good point, Mr. Rom.
Thank you. And
there
one
anything
more
else?
last thing. So can we get some can you tell? I joined a bit late. Can you tell us the models you're using? Like, just curious.
Here, like today, the model which I have implemented.
Yeah. It's a stability.ai is a diffusion model. So just want to know like the model
Yeah,
name.
it's a diffuser model which was basically a Hugging Face implementation. It's called Demo
Okay,
YLab text to
Hugging
video
Face. Okay.
generation. Yeah, text to
Got it.
YLab Demo YLab text to video generation by Model Scope. You can take a look at this in the Hugging Face website if you're really interested
Right.
to explore further.
Okay. Thank you so much.
Yes, sure.
Any other questions, audience?
Yeah, one last question I have.
Yes, sir.
I'm like personally very much interested to develop some good generative AI solution, but I do know the difficulties that lie ahead. But I want to so if that is the scenario, whom I should like, because I'm not that much conversant with all the intricate details. Like I do know the necessary GPU hardware and all that stuff, and the PyTorch Lightning libraries, all that. But then that is not enough for this particular solution development. I want to get involved very seriously. So how do I go ahead?
So Srini, that question I guess I can answer. So that's what we are here for, Cellstrat, right? You have joined our community, I believe, right? So reach out to me. We are supporting many product startup launches, if you will. We are we are not properly an accelerator, but we are a bit of a startup incubator. So reach out to me and we can discuss how Cellstrat can support your product launch if we can. So obviously, if we have to engage some resources, generally that needs some funding, availability. But if you are good yourself a developer, you can do it yourself. But if you are not and you need other developers to engage, then there will be some budgetary requirements. Yes. Or you can excite somebody to become your technical CTO co-founder, right? So that is the other way to do it.
Okay. Vivek, I have seen today one video from Assembly AI.
Yes.
Where that's a very interesting use case, where they have trained audio data of 1.1 million audio files to.
So Srini, there are so many. There are zillions of product ideas. We have to pick our battle. We can't tackle too many situations. So we'll have to pick our battle. So we can discuss offline how to narrow our product ideas.
I'll ping you in WhatsApp and then we can take it up.
Sure. Absolutely.
Yes.
One last question. Are you having some groups like GenAI groups or something? I would love to join.
Yes. Om, just reach out to me. I have shared my number. So I'll show you how you can join a research community.
Sure. No, I just go. Okay. Thank you so much. Yeah, got it.
So just note my number. I am Vivek Singhal, Chief Data Scientist with Cellstrat AI Lab. So we have multiple WhatsApp kind of communities where we do variety of programs like internships and research and general collaboration. Okay.
Definitely, that will be very helpful for me, Vivek.
Please reach out to me. We can set up some time for an offline conversation.
Definitely. I'll definitely get in touch with you. Yeah.
Sure. Any other questions, audience? Okay, so Naganushit, a fantastic presentation. Beat all my expectations. So awesome work. And I am very excited to see your future work in Cellstrat. All right.
Sure, sir. Thank you so much, sir.
Thank you, Naganushit. Well done. Thank you, audience, for joining. Have a good day.
Thank you, everyone. Thank you.